Good afternoon, guys. Today we are dealing Unit 2, classification of fluid flows and the problems. So today we are discussing the fluid flow problems and also the concept of continuity equation. In the last class, we have discussed about the methods of fluid flow, describing the various fluid flow properties. Now, in this class, we'll discuss what are the various types of classification of fluid flows, how do they behave when they are flowing in any container or a pipe, and what are the various types of continuity derivation for one-dimensional and three-dimensional flows, and what are the problems associated with that, right? Okay. So now we are in the lecture 18. So we'll start the class. So now we are discussing the classification of fluid flows, classification of fluid flows. Okay, so now what are the various types of fluids flows? That is a steady flow, unsteady flow, laminar flow, turbulent flow, rotational flow, rotational flow. Like this we have discussed in the last class. So now we are balancing the other type of fluids, that is the rotational or irrotational flows. Now we'll see what are the rotational or irrotational flows. So the motion of a liquid in a rotational tank, the motion of a liquid in a rotation tank is nothing but a rotational flows. So in the last class, I have gave an example of your transit mixture. Transit mixture means the vehicle where the mixture is continuously rotating for making the slab of any building, right? So this is an example of rotational flow. Then what is an example of a rotational flow? A flow is said to be rotational if the fluid particles which for flowing along the streamlines do not rotate about the axis. Flow outside the boundary layer is generally considered as irrotational. So ఏదైతే మనకి ఈ rotational లో కాకుండా outside boundary లో whatever the water is having, generally flowing in the rivers or streams or any pipes, those are nothing but the irrotational flows. Now, the last one is one dimension, two dimension, three dimension flows. The last type of classification of fluid flow is a one-dimensional flow, two-dimensional flow, and three-dimensional flow. In this flow, one-dimensional flow is a type of flow in which the fluid parameters such as velocity is a function of time and space coordinates only, say x. So generally in the space coordinates we are having x-axis, y-axis, and z-axis. So in a one-dimensional flow, only the velocity is taken with respect to the time. Okay, here only the velocity is taken with respect to the time. With respect to time, in which axis? In x-axis. In x-axis, velocity with respect to time in x-axis. For a steady one-dimensional flow, the velocity is a function of one space coordinate only. One space coordinate only. The variation of velocities in other two mutually perpendicular directions are assumed negligible. So in case of one-dimensional flow, what's happening means the other dimensions, other axes such as y-axis and z-axis is negligible. We are making them as 0. Only the x-axis is we are considering. Only the x-axis we are considering. Therefore, if you see the one-dimensional flow, u is equals to fx. So what we are considering here, we are considering velocity as a function of time. So when we are considering velocity as a function of time, u is equals to fx, v is equals to 0, and w is equals to 0. So why we are indicating? Because the variation of velocities in other two axes are totally negligible. That's why manaki v anedi 0, w anedi 0 pettukunnamu. Only we are considering f of x. where u, v, w are velocity components in x-axis, y-axis, and z-axis. In some other textbooks, you can see A, B, C, or I, J, K, or P, Q, R. ఎక్కడైతే UVW ఉన్న places లో, you see in other books you can see PQR or LMN or ABC or IJK, like that. Don't confuse. Here what is the main thing is only one direction, only one axis is active, one axis is active in the one dimensional flow. Now if you see the two-dimensional flows, it is a type of flow in which the velocity is a function of two space coordinates, say x and y. Okay, velocity is a function of time and two space coordinates x and y. So for a steady two-dimensional flow, the velocity is the function of two space coordinates only. So the third one is negligible. The third one is a negligible. Okay. So if you are taking the third one is totally negligible. So if you see this one, thus u is equals to f of x comma y, v is equals to f of x comma y, and w is equals to, that is 0. Why? We are taking the third coordinate as negligible. That's why we are taking only x-axis and y-axis. That's why u is equals to f of f1 xy, v is equals to f2 xy, w is equals to 0. That is nothing but two-dimensional flow. Next one, three-dimensional flow. So it is a type of flow in which the velocity is, the three-dimensional flow is a type of flow in which the velocity is a function of time and three mutually perpendicular directions are considering. Okay, here now see the parameters of functions of three space coordinates. Now we are considering x-axis, y-axis, z-axis in the space. Therefore, how you are writing, see here, u is equals to f1 xyz, v is equals to f2 xyz, z is equals to f3 xyz. So like this we are taking three axes with respect to the u comma v comma w. So like this you are having one-dimensional flow, two-dimensional flow, and three-dimensional flow. Next, if you see the figure of these three things, if you see the one-dimensional flow, see the one-dimensional flow. Here the liquid flow is passing in a channel in this fashion, one direction only. You don't have the y and z direction. If you see this one, it is going only in one direction. If you see the two-dimensional flow, here the water is passing in this way. X, and it is taking some other direction. Again, it is taking the same direction and it is going in the same direction. So here plus x going in one way, here y-axis. So y it is going in this way. Again, mali lopaliki vachindi, means minus 5 plus 5. Here we are considering x-axis in this way, y-axis in this way. Thereby, it is nothing but a two-dimensional flow. Now, three-dimensional flow. So see here. So it is a tapered section where the water is flowing inside this channel. Here we are having the water is flowing in, see this, here it is having a concave shape. So it is moving in a small aperture to the large aperture. Here it is taking three mutually axis, x-axis in this direction, y-axis in this direction as usual like this, and z-axis in this direction. So you are having totally x, y, z, three axis dimensions, depends upon the section how you are making. So like this, the classification of flows are classified into 6 types of classifications. So in that we have discussed all the types clearly. Okay. Next. Okay. Three students were present. Okay. Snehalata. Only these four members are coming regularly. Snehalata, Falguna, RAJESH.K and Sandeep. So why other students are not coming? So just inform them to participate in the class. It is very, very important. So these are real classes, not time pass classes. Ask your friends to join in the session live. Okay. Next topic is rate of flow or discharge Q. How much amount of fluid is passing in the container or a section or some chamber. Okay. It is defined as the quantity of fluid, the quantity, how much it is flowing, quantity of a fluid flowing per second through a section of pipe or channel. So that is nothing but a rate of flow. The rate of flow means it is a quantity of a fluid passing in any container per second is nothing but the rate of flow or a discharge. For an incompressible fluid, the rate of flow is expressed as the volume of the liquid flowing across the section per second. Or compressible fluids, the rate of flow is usually expressed as the weight of flow flowing across the section. So incompressible fluids flow. For incompressible fluids, the rate of flow is the volume of cross section per second. Whereas for compressible fluids, the rate of flow is expressed in the weight of fluid flowing across the section. Thus, thereby for liquids, the unit of Q is meter cube per second or liters per second. Whereas for gases, the unit is kgf per second or Newton second. Therefore, the discharge Q is equals to area into velocity of the fluid. Area and area of the cross section of a pipe. It may be a pipe or a container or any chamber or any container or any item or any liquid carrying container. V is equals to average velocity of the fluid across the section. What section? The cross section of a pipe. Thereby, Q discharge is equals to A into V. Whenever you are taking liquids into consideration, Q is equals to A into V, meter cube per second or liters per second. Whenever you are considering gases, it is Q is equals to kgf into second. Okay, now next. The next one is Reynolds number. Reynolds is a person. He gave the definition for the inertia versus force. It is defined as the ratio of inertia force of a flowing fluid to the viscous force of a fluid. It is a dimensionless number. Dimensionless number అంటే MLT, M, L square, T minus 1 ఇవన్నీ మనం యూనిట్ 1 లో చెప్తున్నాం dimensions గురించి. So it is saying that it is a dimensionless number. So Reynolds number is defined as simply the ratio. See the ratio RE is equals to inertia force of the fluid by viscous force of the fluid. Inertia force is equals to F by I is equals to inertia force by V is equals to viscous force. Therefore, RE is equals to rho VD, force is equals to rho VD by viscous force F is equal to mu. That implies VD by V. Rho by mu is equals to V, 1 by V, that is equals to V. Therefore, mu is equals to viscosity of a fluid, V is equals to velocity of a flow, D is equals to diameter of a pipe, V is equals to, here V is equals to kinetic viscosity. Now the Reynolds number is very useful parameter in predicting whether the flow is laminar or turbulent. Manaki classification of flows లో laminar flow, turbulent flow అని చెప్పుకున్నాం. So in that laminar or turbulent flow, in order to predict the parameter, the Reynolds number is very, very useful. At low Reynolds number, the viscous forces predominate and allow the laminar. At high values of Reynolds number, the inertia forces overcome the viscous force. The inertia forces overcome the viscous force, friction, and consequently, the fluid layers break up into the turbulent flow. So, when the Reynolds number is high, the inertia forces overcome the viscous forces and consequently break up. The layers are breaking, then thereby you are getting the turbulent flow. The change from the laminar and the turbulent flow is referred as transition. When now there is a change, we are calling them as a transformation or transition took place. Thereby, as discussed earlier, the pipe flow RE Reynolds number is less than 2000, the flow is laminar. When RE value is greater than 4000, the flow is turbulent. According to the table, so there is no confusion. So by seeing the table, when the Reynolds number is less than 2000, we are calling them as a laminar flow. When the Reynolds number is more than 4000, we are calling them as a turbulent flow. That is simply turbulent flow. Next, laws of conservation. So there are three principal laws of conservation. So this type of theoretical things will come for you for the short answer type, short questions type. Define Reynolds number or explain the laws of conservation. So see here, there are three basic laws of conservation used for the analysis of the problems in the fluid motions. First one is principle of conservation of mass. First one is the principle of conservation of mass. Second one is conservation of energy. Third one is conservation of momentum. Okay, na? First one is a mass. Second one is energy. Third one is a momentum. What is a mass? What is a mass saying? It states that mass can neither be created nor destroyed. On the basis of this principle, the continuity equation is derived. So మనం నెక్స్ట్ చెప్పుకునే కాన్సెప్ట్ కంటిన్యూటీ ఈక్వేషన్ గురించి చెప్పుకునేటప్పుడు we will first discuss the mass can be neither created nor destroyed. Okay na? Next, the principle of conservation of energy. It states that the energy can neither be created nor destroyed. It is also based upon the energy equation. Next, principle of momentum or impulse momentum principle. It states that the impulse of the resultant force or the product of force and time increment during which it acts is equal to the change in momentum of the body. On the basis of this principle, the momentum equation is derived. So based upon the law of conservation, each law of conservation is having its own equation. That is a continuity equation for mass and energy equation for the conservation of energy and momentum equation for impulse momentum principle. So these are the derivations of the laws of conservation. Next we'll see the first thing, continuity equation. There is a mass which is related to the mass. Very simple derivation. So if it comes in exam, you can write very easily. So derive continuity equation and check you can write very easily. Right? Now see what the continuity equation says. The continuity equation is based on the principle of conservation of mass. ఇందాక మనం చెప్పుకున్నట్టుగా the continuity equation is the continuity equation. See here, the continuity equation, conservation of mass is said by continuity equation. So what it is saying here, the continuity equation is based on the principle of conservation of mass called as continuity equation. Thus, for the fluid flowing through the pipe at all cross sections. So ఎప్పుడైతే fluid is flowing through the pipe at all cross sections, the quantity of fluid per second is constant. So whenever the fluid is passing in a pipe in all the cross sections, so pipes different bends ఉంటాయి కదా, whenever the water is flowing in a different pipe sections, the quantity of a fluid per second is constant అని చెప్తున్నాడు. Per second is constant. Now consider two cross sections of the pipe. So దీనికి మనము డెరివైవ్ చేయాలంటే just we'll take an example. Just consider a section of pipe. So మనకి ఒక పైప్ తీసుకున్నాము, పేపర్ పైప్. పేపర్ పైప్ తీసుకొని రెండు చోట్ల మనము క్రాస్ సెక్షన్ చేసుకున్నాం, రైట్? So 2 points we took the cross section. Here section 1 and section 2. Now the liquid is flowing in this direction. Okay, now the liquid is flowing in this direction. Now see, let's consider V1 is the average velocity at cross section 1. So ikkada manam 1 దగ్గర we'll take the values. V1 is the average velocity. Rho1 is equals to density of a fluid. A1 is equals to area of the pipe. So section 1 దగ్గర మనం 3 values తీసుకుంటున్నాము. What are these values? Velocity values, area values and density values. And V2, Rho2, A2 are the corresponding values at 2. So from this figure, V2 దగ్గర ఏం తీసుకున్నాం? The same values A2, V2 and Rho2. Very simple కదా. Next, the rate of flow. Next ఏంటి? The rate of flow at section 1 ఏంటి? A1 V1, A1 V1 Rho1 sorry ఇక్కడ Rho1 ఉంటుంది. Rho1 into A1 into V1. The rate of section at 2T is equals to Rho2 into A2 into V2. According to the laws of conservation of mass, what it is saying? The rate of flow at section 1 is equals to rate of flow at section 2. So ikkada em cheptundi? Both are equal and both are same. So what it is saying, on the basis of the principle, it can either be created nor destroyed. So it is saying that the laws are equal. Now according to the law of conservation, section 1 is equal to section 2. There, that is Rho1 into A1 into V1 is equals to Rho2 into A2 into V2. Now this equation is applicable to the compressible as well as incompressible fluids, and called as continuity equation. If the fluid is incompressible, then 1 is equals to 2, and the continuity equation reduces to A1 V1 is equals to A2 V2. So ఎప్పుడైతే the fluid is incompressible, so the continuity equation అనేది compressible కి and incompressible fluids కి applicable అవుతుంది. Whenever the fluid is incompressible, then Rho1 is equals to density 1 is equals to density 2. Density 1 is equals to density ఉంటుంది. Density Rho1 is equals to Rho2. Thereby the continuity equation ఎలా అయిపోయింది? A1 V1 is equals to A2 V2 when it is for incompressible fluids. Okay na? Right. Okay. Next one, continuity equation in 3 dimension. So మనం ఇందాక చూసుకున్నాం అనేది continuity equation in a 1-dimension flow. Now we'll see the continuity equation in a 3-dimension flow. Now see clearly, we are having a 3-dimensional object A, B, C, D, F, A. So ఒక box వేయండి, ఒక rectangular square box A, B, C, D. Okay, A, B, C, D in YZ line, B, F, G, C for XY line, and A, E, H, D is for top end, that is XY top, and H, G, E, F is for XY, this right side. So like this you are having a 3D object. So దీనికి మనకి you are having X కి U ఉంది, Y కి B ఉంది, Z కి W ఉంది. Okay na? Now see the distance from A to B is dx in x-axis. The distance from this is dy y-axis. The distance from center to the top, that is dz in the z-axis. Now see what the continuity equation is saying. Here, consider a fluid element of length dx, dy and dz in the direction of x-axis, y-axis and z-axis. Okay, first మీరు ఎగ్జామ్కి వచ్చినప్పుడు derive the continuity equation in 3-dimension flow అన్నప్పుడు first draw this figure. First write x-axis, y-axis, z-axis. తర్వాత 0 పెట్టుకొని ఆ 0 దగ్గర నుంచి u for x-axis, v for y-axis, w for z-axis మెన్షన్ చేయండి. తర్వాత ఒక క్యూబాయిడ్ ఒక 3D ఆబ్జెక్ట్ తీసుకొని x-axis, y-axis, z-axis మీద ప్రొజెక్ట్ చేసి name it ABCDEFGHIJK, name it, because you are having how many sides? 4 plus 1 2 3 4 5 6 7 8, right? You are having 4 1 2 1 2 3 4 5 6 sides you are having. So just name it and show the distances dx comma dy comma dz. Let u comma v comma w or the inlet velocity components in x-axis, y-axis and z-axis. Just show like that. Then the mass of fluid entering the phase ABCD, the mass of fluid entering the phase ABCD per second. So ఇప్పుడు మనము ఒక పార్ట్ తీసుకున్నాం ABCD. So ఇక్కడ నుంచి when the fluid is entering, right, the fluid element of length, దీంట్లో the fluid element of length లో this is entering into the, this particle is entering into the mass, this particle is entering into the pipe. Then the mass ABCD per second is equals to, mass is equals to rho into velocity in x direction, velocity in x direction per area into ABCD, area of ABCD. Now ఈ డైరెక్షన్ లో వెళ్తుంది కాబట్టి దీని వరకే మీరు కన్స్ట్రక్ట్ చేయండి. సో ఈ డైరెక్షన్ లో వెళ్తుందంటే ఇటు x axis డైరెక్షన్ లో వెళ్ళింది. సో rho into velocity in x direction into area of ABCD. Now rho into velocity u into velocity next direction ఏంటి u కదా u, then area of ABCD ఎంత dx into dy, sorry, area of this one y axis లో dy, z axis లో dz, therefore dy into dz. Next, then the mass of fluid leaving the phase, a fluid mass అనేది the mass of fluid leaving this phase, ఎక్కడి నుంచి phase లీవ్ అవుతుంది EFGH లోంచి బయటికి వెళ్తుంది. Then how we are considering? Same, p into rho into velocity in x direction into area EFGH. Therefore rho into u into dy dz plus dou by dou x rho u dy dz into dx. Why? Because the x axis మనం consider చేస్తున్నాం కాబట్టి we don't have x axis, that's why we are taking this as x axis as a derivative. Therefore gain of mass in x direction, gain of mass in x direction is equals to mass through ABCD minus mass through EFGH. That implies mass ABCD as it is equal to substitute చేయండి, rho into u into dy into dz, rho into u into dy into dz minus substitute this value here. So minus పెట్టేసాము. తర్వాత total value, this total value substitute at this point, at this rho into d into dy dz minus dou by dx, rho u into dy dz into dx. Now so you got this value, mass through ABCD minus mass through EFGH. Now after substituting this one, we are getting minus dou by dou x rho u dou y dy dz into dx. అంతే కదా. సో this one ఈ రెండు క్యాన్సిల్ అవుతాయి, we'll getting the same value keeping here. Next, దీని ఇంకొంచెం derive, దీని ఇంకొంచెం చేస్తే we are getting minus dou u by dou x rho u dx dy dz. సో దాన్ని బయటకు తీసుకొచ్చేస్తాం. నెక్స్ట్, similarly the net gain in mass in y direction. సో y direction, z direction, x direction ఇది వచ్చిందంటే y direction కూడా ఇవే మీరు చేసుకుంటే మీకు ఇది వస్తుంది. సో జస్ట్ ఇక్కడ చేంజ్ ఏమైంది, y direction తీసుకున్నాం అంటే ఏం జరిగింది, y there is xz, సేమ్ ఇట్లానే xz ఇట్లా బయటకు వస్తాయి అనమాట, xz like this. Now after getting, we will get minus dou u by dou y rho into v dx dy dz. Next, z direction same. So like this we are getting x axis లో ఒకటి, y axis లో ఒకటి, z axis లో ఒకటి, మూడు వచ్చింది. Now the net gain of the masses, so we are taking all the three xyz axis. Now we are saying it as therefore net gain of the masses is equals to minus కామన్ గా పెట్టుకొని ఈ మూడు వాల్యూస్, this one, you are putting here. So dou by dou x plus dou by dou y dou by dou z. So rho u, rho v, rho w bracket lo dx dy dz. Okay na? Now since the mass is neither created nor destroyed in the fluid's tree element, the net increase of the mass per unit time in the fluid element must be equal to the rate of increase of mass of the element. So next దీన్ని చేసుకున్న తర్వాత ఏం చేస్తాం? So we are saying this as equating the two expressions, equating these the two expressions with respect to the dou by dt rho of dx dy dz or dou rho by dou t dx dy dz. So see here equation same అదే equation ఇక్కడ రాసాము into d is equals to dou rho by dou t dx dy dz. Now దీన్ని కొంచెం సింప్లిఫై చేస్తే dou rho by dou t plus, సో దీన్ని ఇటు సైడ్ తీసుకొస్తే సో dou by dou x dou u plus dou by dou y dou v dou by dou z dou w that is equals to 0, cancelling this for both sides. సో అప్పుడు మనకి ఇది క్యాన్సిల్ చేస్తున్నాం, ఇది క్యాన్సిల్ చేస్తున్నాం కాబట్టి that is equals to 0, that is equals to 0. Now this equation is a continuity equation in Cartesian coordinate system. Cartesian coordinate system ante moving in x direction, moving in y direction, moving in z direction. Cartesian ante 3-axis system. Cartesian or prismatic antam. X axis, y axis and z axis. Now this equation is applicable for what type of problems? Steady flow and unsteady flow, uniform flow and non-uniform flow, compressible flow and incompressible flows. అప్పుడు దీనికి ఈక్వేషన్ చూసుకున్నట్లయితే, సో దిస్ ఇస్ ద ఫైనల్ థింగ్ ఫర్ దిస్ ఈక్వేషన్ ఫర్ స్టడీ ఫ్లో dou rho by dou t is equals to 0. Hence this formula can be written as dou by dou x by rho u plus dou by dou y by rho v plus dou by dou y by rho w is equals to 0. Okay na? If the fluid is incompressible, then the rho is constant and above equation is written as rho constant అయినప్పుడు ఏం జరిగింది? dou u by dou x plus dou u by dou y plus dou by dou z is equals to 0. It is for incompressible fluids. Next, if the formula is the continuity equation in 3 dimension, for the 2-dimensional flow, the component w is equal to 0 and hence continuity equation is. So ఇది మనం 3-dimensional గురించి చెప్పుకున్న డెరివేషన్. అదే మనకి 2-dimensional వెళ్ళినప్పుడు ఏం జరుగుతుంది? u v w. So w will be 0. Therefore dou u by dou x plus dou u by dou v by dou y is equals to 0. That is for the 2-dimensional flows. So మీకు కంటిన్యూటీ ఈక్వేషన్ 1-dimensional flow ఇందాక ముందు చెప్పుకున్నట్టు it is the 1-dimensional flow. See this a1 v1 is a 1-dimensional flow, 2-dimensional flow, 3-dimensional flow. ఈ మూడు మనము ఒకే దానిలో డెరైవ్ చేసాము, రైట్? అండర్స్టూడ్? Total 7 members present. Good. Today the number increased. Today కొత్తగా ఎవరు వచ్చారు? నరేంద్ర, రమేష్ సేమ్ ఓల్డ్, రవితేజ, పాల్గొన్న, RAJESH.K, స్నేహలత. సో వీళ్ళందరూ పాత వాళ్ళు. కొత్త వాళ్ళు ఎవరు వచ్చారు? నరేంద్ర. ఓకే ఓకే నెక్స్ట్. సో ఇంతవరకు అర్థమైంది కదా? ఎనీవన్ క్లియర్డ్? అర్థమైందా? ఎస్ ఆర్ మేక్ raise your hand. అర్థమైన వాళ్ళు raise your hand or message me. Understood the derivation of 1-dimensional flow, 2-dimensional flow, 3-dimensional flow? The confirmed question. Gettiga classification of flows, definitions and derive the continuity equation of question వస్తుంది. అర్థమైనయా? Just chat me or raise your hand. అర్థమైన వాళ్ళు raise your hand. రమేష్, రవితేజ, నరేంద్ర, పాల్గొన్న, RAJESH.K, సందీప్. Understood? Yes. Okay. No one is answering. Okay. Next we'll go to the 2 problems. With this we'll stop the class. Now see the diameter of the pipe, the diameter of the pipe, the cross section, the diameter of the pipe of cross section 1 and 2 are 10 centimeters and 15 centimeters. So from the figure low, section 1 దగ్గర diameter is 10 centimeter, section 2 దగ్గర diameter is 15 centimeter. 15 centimeter. Okay. If the velocity of water flowing through the pipe, yes.
ఇంట్రెస్ట్ ఉందిలే, అన్ని చదవగలము అనుకుంటే ఏదైనా తీసుకునే ఏదైనా అంతే ఉంటుంది.
Ramesh, you are discussing to me. You are talking to me. Ramesh, are you talking? Your audio is having some Yes. See the problem here. See the problem. Ramesh, please don't talk. Yes. So if you see the problem, here, the cross section 1 you are having 10 centimeters, cross section 2 you are having 15 centimeters. If the velocity of water flowing through the pipe at 1 is 1.5 meters per second, and find the discharge at 1 at section 1 through the pipe. Second point, velocity of water section 2. So ఇక్కడ ఏం చెప్పాడు, స్ట్రీమ్ దగ్గర section 1 దగ్గర the diameter is 10 centimeter, section 2 దగ్గర diameter is 15 centimeter. If the velocity of water flowing through the pipe at section 1 is 1.5 meter per second అయితే, then find discharge through the pipe 2. ఇక్కడ discharge ఎంత ఉంది and velocity of this water at section 2. Okay na? Now see, you write the given data. Given data is equals to diameter of the pipe section 1 దగ్గర రాసుకోండి first. D1 is equals to 10 centimeter, conversion into meters 0.1. Area A1 is equals to pi by 4 D1 square. అంతే కదా, ఏరియా కనుక్కోవాలి. Pi d square by 4. Pi by 4 into 0.1 square is equals to 7.854 10 to the power of minus 3 meter cube. Next, velocity ఎంత ఇచ్చాడు క్వశ్చన్ లో, V1 is equals to 1.5 meters per second. Next, diameter of pipe at that section 2 తీసుకుందాం. D2 is equals to 15 centimeters, that is equals to 0.15 meter. Then consider the area A2 is equals to pi d square by 4. Therefore, the answer is 17.67 into 10 to the power of minus 3 meters square. Now, what is the thing you have to find? Discharge through the pipe 2. Pipe 2 దగ్గర discharge ఎంత ఉంది. Now, the discharge formula ముందు మనం చెప్పుకున్నాం కదా, which one in the continuity equation లో Q is equals to AV అని చెప్పుకున్నాం. See here, Q is equals to, we have discussed Q is equals to AV. See here, Q is equals to AV, the discharge, rate of discharge. Rate of discharge is equals to Q is equals to AV. Okay na? So ఇక్కడ మనకి 2 sections ఉన్నాయి కాబట్టి we can take A1 V1 na A2 V2 na. Okay, A1 V1 or A2 V2. Now see here, take A1 V1. So first మనకి discharge A1 V1 దగ్గర తెలిస్తే we can go for, therefore discharge through the pipe, this is discharging. If you are inletting, this is discharging outside. Q is equals to A1 into V1. A1 is equals to 7.8 into 5 V1, that is equals to 0.03. That is the answer of the discharge through the pipe. Then velocity of water at section 2. Velocity of water at section 2. V2 కనుక్కోవాలి velocity. So velocity కనుక్కోవాలంటే by using the continuity equation, A1 V1 is equals to A2 V2. Therefore v2 తీసుకొచ్చేసి a1 v1 by a2 తీసుకుంటే substituting direct values you are getting the answer 2.2 meters per second. Hope the problem is very easy, right? Problem అర్థమవుతుంది అనుకుంటా ఈజీగానే. నెక్స్ట్ problem. The water is flowing through the pipe. The water is flowing through the pipe 0.5 meters diameter with an average velocity of 1 meters per second. Okay, the diameter of the pipe is given 0.5 and the velocity is given 1 meter per second. What is the rate of discharge? What is the rate of discharge of water? The same flow then passes through the another section where the diameter is 1 meter. ముందు diameter లో 0.5 ఉంది. అదే వాటర్ వేరే క్రాస్ సెక్షన్ లో వెళ్ళినప్పుడు diameter of 1 meter. What will be the average flow velocity at this section? Very simple. So you can draw the figure. And what is the given data? D1 is 0.5 meters. Velocity is 1.1 meter per second. Then what is the rate of discharge? Rate of discharge at section 1 or at this thing is Q is equals to A1 V1. Area enta manaki by taking this one 5d square by 4. Area is equals to 5d1 square by 4 into V1, that is equals to 0.1963. Okay na? Next. Let V2 be the velocity where the diameter is 1 meter. So for the same formula తీసుకొని Q is equals to A1 V1 or A2 V2. So V2 is equals to A1 V1 by A2. అప్పుడు substituting A1 V1 0.913 పైన పెట్టేసి A2 is equals to 5 by 4 d2 square into velocity. Therefore V2 is equals to 0.25 meters per second. Hope you understood this problem, right? So the time is short, running short. So we'll stop the class here. I have the next class 3 o'clock for your seniors. So if you have any doubts, just open your mic or just chat me in the chat box. Understood the derivation of continuity equation, the rate of discharge and the problems. Andamainaya, just chat me. Understood or not? Just message me. Up to now topics అన్ని అర్థమైనయా? Anyone? Just message me. Ramesh, Raviteja, Narendra, just message me. Problems are fine. Topics are okay for you. అర్థమవుతున్నాయా? RAJESH.K, Sandeep, chatting. Ramesh, yes. ఇంకా balance. Narendra, fine, good. ఇంకా రవితేజ అర్థమవుతున్నాయా? ఇప్పటివరకు టాపిక్స్ అర్థమైందా? యూనిట్ 1, యూనిట్ 2. టుమారో క్లాస్లో విల్ స్టార్ట్ ప్రాబ్లమ్స్ అండ్ అదర్ డెరివేషన్. Raviteja, yes sir, fine. Still, Falguna, Sandeep, yes sir, good. RAJESH.K, Sandeep, okay. Raviteja, okay. Ramesh, okay. Narendra, fine. Falguna, I think he's sleeping. RAJESH.K, you're also sleeping. So మీకు హరీష్ కొత్తగా జాయిన్ అవుతున్నాడు. హరీష్ లాస్ట్ 1 minute టైంలో inform your friends to come to class regularly in time. మీ క్లాస్లో 25-27 ఉన్నారని చెప్పారు. గ్రూప్లో కూడా ఉన్నారు, బట్ మెజారిటీ ఆఫ్ పీపుల్ ఆర్ నాట్ కమింగ్ రెగ్యులర్లీ. మీరు మాత్రమే వస్తున్నారు, మీకు మాత్రమే అటెండెన్స్ తీసుకుంటున్నాము. Ask your friends to come regularly from tomorrow onwards. వీడియోస్ చూస్తారు, బట్ ఇక రియల్ టైంలో క్లాసెస్ డౌట్స్ వస్తే వీఆర్ హ్యావింగ్ 2-way డిస్కషన్. అర్థమవుతుందా? అదే కాలేజీలో ఉంటే దట్ ఈస్ అదర్ థింగ్. న్యూ ప్లాట్ఫామ్లో మనం క్లాసెస్ చెప్పుకుంటున్నాం కాబట్టి 2-way డిస్కషన్ ఈస్ వెరీ ఇంపార్టెంట్. Or you provide notes, sir. So definitely the no ఇది కొత్త సబ్జెక్ట్ ఏం కాదు. If you go to library, you are having number of books, or else this PPT is also enough, or else I will provide the material for you so that you can get the information. Make a soft copy ఇస్తాను. Once the college is open, we'll see the hard copy also. And library also are having number of fluid mechanic books. Okay, don't worry about the material, it will be provided. Okay, with this we'll stop the class. I will take the attendance. So మీరు కూడా ఉన్న screenshot తీసుకోండి. So tomorrow we'll go for the next session. So once the class is completed, I will upload your video in the YouTube, and later I'll upload the link in your group. Thanks for watching.